This video is about graphing quadratic functions, and in actuality what I want to start with in this video is identifying pieces of the graph and looking at them so that we know what we're looking for and what our graph should end up looking like. We also need some of this information in order to actually graph the quadratic function. So if you're not sure what a quadratic function is, if you're in my class, you should have a notes-taking guide that looks exactly like this or almost exactly like this. And go ahead and get that out and we'll start taking notes from that. But a quadratic function, there's one written right here. It's just the generic form. It says y equals x squared plus x plus c. So it says ax squared plus bx plus c. The a, the b, and the c are generally replaced with numbers. And the x squared and the x are just part of the function. That kind of function, a quadratic function, will make this U-shaped graph. This is called a parabola. So what we want to be able to do is we want to be able to identify some pieces of the parabola, and there are things about the parabola that you get from the function itself that lets you actually then turn around and graph the function. So what we're going to do in this video is figure out how to get all the pieces that we need so that we can then go back and graph the function. So we're going to start by just identifying some of these things. So the first thing that we want to identify is this dotted line. This dotted line is called the axis of symmetry. The axis of symmetry is just an invisible line that divides your parabola in half. It goes right down the middle of it, and it tells me, hey, on one side of this line is the mirror image of what's on the other side of this line. So it cuts the parabola into two mirrored pieces. And we need the axis of symmetry because it's going to help us get started in finding that first point that we'll graph when we do our graphing. The second thing we need to be able to identify is the vertex. And we want to be able to identify the vertex because the vertex is actually going to be that place where we start graphing. And there's a bunch of different ways to describe it. I usually describe it as the turning point. It's that place in the parabola where it either hits the very bottom of the parabola and starts to go back up, or if your parabola makes an upside down U shape, it's that point at the very top of the parabola where it starts to turn and go back down. So in this particular picture, the axis of symmetry is where you would start. So we would look at this and we go, okay, here's the axis of symmetry. And we look at the axis of symmetry in its relationship to the x-axis. So on the x-axis, the axis of symmetry goes through positive 1. So the axis of symmetry would be x equals 1. The vertex, which is this point right here, is written as an ordered pair. And basically, you just give me the directions on how to get there. So if you went to the origin, you would go right 1 space, and you would go down 4 spaces. So the vertex is at 1, -4. So these are the two things that we're going to really be working on in this video, is finding the axis of symmetry from the function, and then using the axis of symmetry to find the vertex. Because once we have the vertex, graphing it is really very simple. And something else you're going to want to be able to identify, maybe not in this lesson, but in later lessons, are the x-intercepts. Intercepts just mean, hey, this is where that graph crosses that axis. So an x-intercept crosses the x-axis in a certain point. So this graph crosses at -1 and +3. So those are the x-intercepts. The y-intercept would be where your graph intercepts or crosses the y-axis, which in this case is at -3. We won't be using those a whole lot today, but you'll see them in the future. The other thing that we're going to want to identify today is the maximum or the minimum. So when we're looking for the maximum and the minimum, we are actually just looking for that vertex. Is it at the top of the hill, like this one is? Or is it in the bottom of the bowl, like this one? If your vertex is at the top of the hill, then it's a maximum. And notice our parabola makes an upside down U shape. It makes a mountain. When our vertex is at the bottom of the bowl, when it's at the bottommost point of that U shape, it's at its minimum. So it's at its lowest point. And we can actually identify this by looking at the quadratic function itself. So the quadratic function is ax squared plus bx plus c. You can look at the a term, and if it's a positive a, it's going to be a minimum because it's going to make a U-shaped parabola. And if it's a negative a, it's going to be a maximum because it's going to be at the top of the hill. And we'll be identifying whether we have a maximum or a minimum, and we'll be identifying where it's at. Where we're going to start, and this kind of looks like we're going backwards, is with the axis of symmetry, and we need this formula, negative 1b over 2a. We'll need that formula to find our axis of symmetry. One more thing that we're going to add that's not on the notes-taking guide you got in class are the domain and the range. You've done domain and range in classes previously. So the domain is the numbers, let's write this out, the numbers we can plug in for x. So with a quadratic function, it's always all real numbers because we can plug in any number, any real number. So the domain will always be all real numbers, and you can write out all real numbers, or you can make what looks like an R with two backs to it. So I'm going to do it as this just because it's faster. So this is what we can plug in, any number that we can plug into the function. And what happens is when you plug in an x value, you get the range. So this is the values or the numbers that you get. When you plug in the x's. So it's the answers you get when you substitute in it's the numbers you get when you substitute something in for x. So we'll talk about how we're going to write range as we go through the examples. So our first example says y plus 4x minus 2 equals negative x squared minus 7. So we've got kind of a list of things that we need to do, the steps that we need to follow in order to find the axis of symmetry, to find the vertex, to identify whether it's a maximum or a minimum, identify the domain and range, and all of these things we do in preparation for actually turning around and graphing this. So first thing we want to do, let's call this A instead of 1, is we want to make sure that our y, or it might be written as f of x, either one, y, f of x are the same thing, is isolated. So that means it should say y equals, or it should say f of x equals, either one of those things. But you need y to be isolated. This y is not isolated, so we're going to do that first. So I'm going to subtract 4x from the left-hand side. I'm also going to go over here and I'm going to subtract it from the right-hand side. I like to try and line these things up as I go so that I know what actually needs to be combined together. I want to combine this with another x term. There's not another x term over here, so I'm just going to put minus 4x out here on the end. So positive 4x and negative 4x cancel each other out. I still have a negative 2 with the y, so I need to add 2 to both sides. This is a constant, so I can add 2 to this. So these have canceled out, and they've left y by itself. And then I want to write these in the same order that they would be in a quadratic function. So quadratic function would start with the x squared. So there's nothing to combine with negative x squared, so I bring it down. The next thing would be my b term, which is my x term. I have a negative 4x. There's nothing to combine with it, so I'm going to bring it down into my final answer. And then I have negative 7 plus 2, which when I combine those things makes negative 5. So we've isolated our y. And the next thing we want to do is we want to find the axis of symmetry. And I'm going to abbreviate that AS just to make life a little simpler. And we're going to use that formula, x equals negative 1b over 2a. So let's identify our A our B, and our C. If we do that, it just makes it a little bit faster to get our work done. So my A term is whatever's in front of my x squared. There's just a negative there, so that's an understood one. So -1 is A. B is -4, and C is -5. So these are the numbers that I'm going to use in this formula. So x equals -1 times my B is -4 over 2 times my A, which is -1. And then we're just going to solve this little expression. -1 times -4 is 4. 2 times -1 is -2. And 4 divided by -2 is -2. So x equals -2. That's my axis of symmetry. I'm going to write x equals -2. The next thing I need to do is I need to plug x in, which is my axis of symmetry, into the original quadratic. So I'm going to take this as my original quadratic because it's in the right format, and I'm going to plug this -2 in everywhere I see an x. So y equals negative, parentheses, -2 squared. Anytime you plug in to an already existing function, you need to put parentheses around whatever it is you're plugging in, whether it's a positive number or a negative number. Plug that in with some parentheses around it. Then you don't have to worry about it turning up and giving you weird numbers, because sometimes the positive squaring and negative squaring will do that. So then what I'm going to do is I'm going to take this new expression that I have written down, and I'm just going to put the entire thing in my calculator. So negative times -2 squared minus 4 times -2 minus 5. I'm going to put all of that in my calculator, and I find that y equals -1. So I found my axis of symmetry. I have figured out what y equals. So x and y make an ordered pair, and that's my vertex. So I'm going to take this x and this y, and I'm going to put them in an ordered pair. So -2, -1. So that's the turning point of my parabola. Now I need to identify whether I have a max or a min. And I do that by looking at my A term. So if my A term is positive, then I have a minimum. If my A term is negative, then I have a maximum. And the value of that is whatever my y value was. So if I go back to my ABC here at the top of my problem, there's my A value. My A is a negative number. A negative number means I'm going to have a maximum. So I'm going to have a maximum. And its value is whatever my y was. So my y was -1. So my maximum is -1. That just simply says, hey, my graph crosses the y-axis, or it doesn't necessarily cross the y-axis, but my graph goes as far up as -1 on the y-axis. So that's how we do our maximum and our minimum. And then the last thing we want to do, it's just so many pieces, is our domain, which is always all real numbers. And we want to do our range. And we're going to use that y value that we calculated, and we're going to use our A value to find our domain and our range. So if A is positive, then we're going to say that y is greater than or equal to whatever my y value was. Because what the range is saying is the range is looking at the parabola, and it's saying, where does my graph go? From my maximum or my minimum, where does my graph go on the y-axis? So if my A is positive, that means my parabola opens like this, opens as a U shape. So that means it goes up from there. So all of my y's are greater than whatever that minimum is. If my A is a negative number, my graph is going to be y is less than or equal to whatever the y value is. So if my graph looks like this, my y value is here, it's a maximum, and all of my other y's are going to be smaller numbers than that. So for this first problem, our domain is all real numbers, and our range, we had a negative a, we had -1 as our a. So if a is negative, we're going to say y is less than or equal to, and my y value that I calculated was -1. It feels like a lot of work, but once you kind of get into a groove with it, it actually goes fairly quickly. So I'm going to try and keep these steps visible and work a few more problems with you. So I'm just going to kind of divide this page all the way down. And this will be our second problem. And our second problem will make it a little bit easier, maybe. It's not any less work. It's still going to have to do all those steps. So our new problem is y equals x squared plus 4x. And we want to do, I'm going to rewrite like a shorter version. So first thing, are we in y equals format? Yes, we are. We're good there. Second thing, let's find our axis of symmetry. X equals -1b over 2a. So let's identify our a, our b, and our c. A is in front of 1. There's an invisible or an understood 1 there. B is in front of the x, so in this case it's a +4. There isn't a constant out here. There isn't a c, so c has a value of 0. So we're going to take that formula, -1b, so -1 times b, which is 4, over 2 times a, which is 1. So I get -4 over 2, which reduces to -2. So I found my axis of symmetry. Then I'm going to plug it in. So plug x into the original. So I'm going to take this -2. I'm going to go back to y equals x squared. I don't know why I'm putting an x there. I'm going to take that x out, and I'm going to replace that x with a -2 squared plus 4 times -2. And then I'm going to do all of that in my calculator. Parentheses -2 squared plus 4 times -2. We get that y equals -4. So we found our axis of symmetry. We plugged that axis of symmetry into the original quadratic. So now we've got to write down our vertex. Remember, our vertex is our x and our y as an ordered pair. So my vertex is -2, -4. And then I have to do a couple more things. I have to go, hey, do I have a max or a min? And what's my domain and range? So, see if I can get all of this on the screen here together. Probably not. All right, so if we are trying to find our maximum, our minimum, we look at our a value. Our a value is a +1. So if it's a positive number, our problem has a minimum. And then the value of that minimum is whatever our y is. So that's -4. Everything, all of the quadratics we're dealing with, have a domain of all real numbers. And they have a range that starts with an I, or with the y. And we go here, this is from the first page of notes, and it says if a is positive, its y is greater than or equal to, and then we go back to that y value. That y value is -4. So our range is all of the y's that are greater than or equal to -4.